Jupiter is the largest planet in the solar system, and the gas giant's atmosphere is one of the most turbulent regions in our planet's vicinity. You may already know about the Great Red Spot, which in itself is bigger than the Earth. But the James Webb Space Telescope discovered a new feature on the planet, a high-speed jet speeding over its equator. Though NASA's James Webb Space Telescope, JWST, was initially touted as having the power to unveil our universe's furthest horizons, and it surely has, some of the observatory's most gorgeous images are actually ones of our very own solar system. With its gold-plated hive of mirrors and backpack of infrared equipment, such as the near-infrared camera and IRCam, the James Webb Space Telescope has reintroduced us to the stunning place we call home, making us feel like we're seeing our planetary neighbors for the first time all over again. It even offered us a poignant view of Neptune's frail rings, something that hasn't been done for 30 years. But on Thursday, October 19th, scientists announced that, beyond offering us fresh eyes on the solar system, the JWST's images of our cosmic neighborhood are also presenting us with new data about a planet we thought we knew quite well, Jupiter. Images the observatory took of the gas giant last year have managed to show us brand new things about its moons, atmosphere, and rings. Yes, Jupiter has rings too. Basically, after examining images the JWST captured of Jupiter in 2022, a team of researchers realized there's a high-speed jet stream on the planet that's more than 3,000 miles, 4,800 kilometers, wide and traveling at about 320 miles per hour, 515 kilometers per hour. This is something that has never been seen before. That totally surprised us, Ricardo Huso of the University of the Basque Country in Bilbao, Spain, and lead author on a paper describing the findings, said in a statement. It's amazing to me that, after years of tracking Jupiter's clouds and winds from numerous observatories, we still have more to learn, Lee Fletcher of the University of Leicester in the United Kingdom, a member of the new study, said in the statement. What could this mean? According to the team, this newfound jet stream on Jupiter, that's blasting away at about twice the speed of a Category 5 hurricane on Earth and sits right above the equator, might shed some light on the planet's turbulent atmosphere. In fact, all of those 2022 Jupiter images might help researchers deduce what goes on in the skies of the apricot-striped orb. What we have always seen as blurred hazes in Jupiter's atmosphere now appear as crisp features that we can track along with the planet's fast rotation, Huso said. Jupiter is notorious for its extreme weather. You might have heard of Jupiter's Great Red Spot, for instance, which is a never-ending, enormous storm that's so huge it's visible from our vantage point on Earth with a regular old optical telescope. And, importantly for science investigations, Jupiter's atmosphere is layered, like Earth's. This means wind speeds in different layers are probably contributing to the giant planet's tumultuous climate. It's also why Huso and fellow researchers hope to compare what the JWST's infrared vision has seen among Jupiter's high-altitude atmospheric layers, which revealed the new jet stream via some cloud-related features, with what the Hubble Space Telescope has already seen in deeper layers. Hopefully, that'll give us a pretty clear picture of those wild Jovian winds. In fact, Hubble images, which are primarily associated with the visible and ultraviolet parts of the electromagnetic spectrum, have already helped out, offering information about what the area around Jupiter's equator usually looks like, so the team could have a baseline before studying JWST's equatorial jet stream data, and regarding other storms in the region unrelated to the jet. We knew the different wavelengths of Webb and Hubble would reveal the three-dimensional structure of storm clouds, but we were also able to use the timing of the data to see how rapidly storms develop, Michael Wong of the University of California, Berkeley, who led the associated Hubble observations and was a member of the new study, said in the statement. In other words, the team explains, that comparison could help us understand how wind speeds on Jupiter change with altitude and generate what are known as wind shears, which are kind of like wind speed gradients over short distances. The extremely fast jet itself is located about 25 miles, 40 kilometers, above the planet's cloud tops, so if lower winds exhibit much lower speeds, wind shears are likely the result. Jupiter has a complicated but repeatable pattern of winds and temperatures in its equatorial stratosphere, high above the winds and the clouds and hazes measured at these wavelengths, Fletcher said. If the strength of this new jet is connected to this oscillating stratospheric pattern, we might expect the jet to vary considerably over the next 2 to 4 years. It'll be really exciting to test this theory in the years to come. The paper was published on Thursday, October 19, in the journal Nature Astronomy.